Hello, 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 hello. Am I coming out?
You're good. So, Martin Dyster, right?
Yes.
Okay. So, hello everybody. Now we're back into some of the more technical presentations. So this is one where we're going to be talking about 2110 and intercom applications. But before we do that, I wanted to remind everybody that all of these presentations will be posted. And if you'd like to get on the mailing when those are ready, make sure that you take your badge and get it scanned at the front counter. They'll take care of that. There's a QR code you can copy too. Also, the videos from these presentations will be posted at vsf.tv, also on the VSF YouTube channel. So those should be going up in the fairly near future, hopefully within the next few days or maybe a week. But without further ado, Martin, take it away.
Thank you. It won't be terribly technical. I'll just preface that quickly. And if it does get technical, I'm going to rely on Greg, my colleague down there, to just chip in as and when is needed. But what I'm going to do is talk about how we, the Telos Alliance, used the technology behind SMPTE 2110-30 to create a new kind of intercom system. So the first thing I'm going to do is go back in time a little bit of history, and I can see a few systems integrators and broadcasters out there, so this'll ring home with you guys. So in the year 2003, when I was a humble systems integrator, that's what the design of audio systems used to look like, particularly for the BBC, where Mr. Hall over there was one of my customers, in fact. And that's what it used to look like. You know, I'd be regularly changing the oil under a pile of cables like that. And 2003, as circumstance would have it, was also the year, that audio over IP was invented. But I'll get onto that in a second. So moving on from that mess of cables to another mess of cables, I worked on a project in 2003-2004, which was at RTP in Lisbon. And this is a typical project that we worked on. So this was the new HQ for RTP in Lisbon, went live for the Euro Soccer Championships. It was AES3, analog and SDI, audio throughout. It was a huge installation. We were on site for 6 months, designing this massive system of baseband audio, full of all the bits of equipment that we all know and love from way back then, distribution amplifiers, baseband routing, patch bays on absolutely every input and every output, distribution and changeover on every input and every output. All of those kind of things that made my life a living hell back in those days. And that's probably the largest Chrome frame I ever worked on, of however many columns that was and how many tens of thousands of individual pairs that were landed on that. So there's some schematics from that particular period, just to ram it home, you know, with every one of those little boxes, an individual piece of discrete equipment, every one of the red cables on there being an analog audio feed, all of the blue ones being AES3, and all those big chunks of processing and distribution gear that sit in the middle. So what happened when audio over IP came out? Well, audio over IP evolved in the radio industry long before it was ever utilized in TV. And in 2003, the Telos Alliance introduced Livewire. Greg Shea, CTO of Telos over there, was the man who can hold his hand up and say, I'm responsible for audio over IP, it's all my fault, kick me later. So he'll be apologizing in another presentation tomorrow. In 2004, the first IP-based installation went in Auburn, Alabama at a radio station. And then 2006 and 2008, 2010, we started to see some of the protocols that we're familiar with today alongside Livewire. Dante, of course, WheatNet, and Ravenna from ALC networks. So what this moved us on to is the idea that with all these protocols coming out, that eventually an interoperability would be a good thing to have. The X192 committee was formed, and the X192 committee was the driving force behind the AS67 standard. And that's where we got to in 2013 when AS67 was ratified and became reality. And AS67 is really an amalgam of Ravenna and Livewire. I think that's true to say, Greg? Yeah. Media Networking Alliance formed in 2014. And what that did was to further the cause of interoperability with audio over IP protocols. So we started to get into a lot of interop tests, moving audio from Dante systems to Ravenna systems to Livewire systems, WheatNet systems, etc. And AIMS was formed in 2015, and AIMS is a big part of what's going on in this room and a big part of all our lives as we now move into a future where media over IP is becoming the norm for us. So AIMS pushing the industry, not pushing's not the right word, but coaching the industry towards an IP future. And then in 2017, SMPTE published the 2110 standard, which adopts AES67 with a few subtle changes to become the audio format of choice for 2110-30. So everything that's come before leads to 2017. So audio over IP payoffs. I won't go into a lot of detail on this because there'll be a lot of people talking about IP over the course of the IBC show, but one of the more obvious things, it's a layer 3 standard, uses COT switch fabric, uses the PTP version 2 clock, and uses the RTP and SDP standards. I hate reading off a slide, but I apologize. So I'll whiz through a few of these, but looking back at that design of RTP, one of the things that you recognize with audio over IP, certain things disappear. No need for distribution amps anymore, that's done in multicast. Patch bays, you can patch IP, but you don't really end up with a patch bay at baseband level unless you convert everything back to baseband to then patch it to convert it back to IP. So patching's not really something you should be doing anymore. Not good for Gil Meti or people like that, but or Switchcraft, but very good for system designers. Reduces cabling, saves rack space, saves weight, saves design time, as Tim will attest to. His daily rates had to go up because his time in design has gone down. Designs are less complicated, and all associated costs become less complicated. Audio quality is not compromised. We're still, thank you. We're still at 48K 24-bit or higher. And we tend to digitize at the signal source as well with an audio over IP system. So our equipment at the baseband end, now you can buy a microphone with an RJ45 on the back. You can even digitize at the microphone, and then you can convert back to analog at the speaker. So our world is digital throughout now, for the most part. And house sync systems, distribution amplifiers for Black and Burst and for tri-level sync, for AES tone, etc. Those are things that have died away as well. So PTP allows us to get away from that. And also, arguably, a distributed architecture leads to fewer single points of failure, depending on the technology that you're talking about, of course. So intercom, that's why I'm here. I'm here to talk about an intercom system. Life as we know it today. Well, traditional intercom kind of looks like that. Matrix-based intercom exists around a centralized frame with all the component parts, whether they panels or interfaces of any sort, whether it's a VoIP channel that goes out to the internet, whatever, all comes back to a centralized frame. So whether it's one of the next generation of intercoms in a more compact frame size, or whether it's an old 9U of intercom frame, everything ultimately goes back to that central core. And that seems to go against what we're trying to achieve with audio over IP. It doesn't seem that that's necessary anymore. But matrices are practical. There's so many things you can do. I mean, it's there for cross-point switching. I used to work on analog wire per cross-point intercom systems back in the 80s, and that's how the matrix intercom system grew up. It grew up from crosspoint switching in the same way as an audio router does. It's useful for conferencing, for party lines, for IFBs, groups, all those kind of things where more than one person is talking to one thing at a time. Essentially, it's a router and a mixer. Mixing my accents here between router and router. Anyway, very difficult. It should be router, guys. Yeah. And a matrix is a good place to store a central configuration, of course, and also having input cards, output cards, and then crosspoint cards gives you places where you can control gain levels and that kind of thing on the edges, of course. And a few other things that are made easier as a result of that. And matrices can be resilient down to a level, dual power, dual CPUs, but they are still one single point of failure, arguably. And of course, they allow for a wide range of connectivity options. And for a lot of us who are familiar with intercom, haven't really seen it change over decades, get that warm and fuzzy knowing feeling that they've got something that they can rely on. But it's not always a practical solution. No, there's a big limitation. One of the limitations is that when you sit down as a system designer and you have to figure out how big a matrix I'm going to buy, you sit down with a spreadsheet and you say, right, this guy needs a panel, a panel, a panel, a panel, a panel. You might sit down with a desk and tick off all the positions, and this guy needs 16 keys, this guy needs 32. You sit there and you come up with an Excel spreadsheet that at the bottom somewhere has got a number, maybe 129 ports. 128 ports not going to do it. I'm going to have to buy a bigger frame, and then you get to a point when you've installed the system and somebody comes along and says, I've got 10 more panels in. Okay, I need to make this system bigger. So lack of flexibility can be an issue. Channel handling limited by the bus structure, limited by the TDM bus and the number of slots. It can be difficult and expensive to trunk frames together. And so that's another limitation. And they undoubtedly take up a lot of rack space. And as we said before, everything is cabling back to that central point. And even if you have an AOIP system, even if you're using AES67 or SMPTE 2110 to cable your panels, ultimately they are all still coming back to a single point, even if that's a transport link. So you still need the COTS infrastructure in a modern intercom system, even if it's matrix-based using IP. So the challenge for us as a company, who one of the pioneers of audio over IP, working in this space and getting into intercom when I came on board with the company, was to do something different. And we set ourselves one major vision, and that was to do away with the matrix, get rid of the whole of that central core of the product that everybody else recognized and obliterate it, get rid of it completely, and use the power of audio over IP as the catalyst to be able to do that. So our rules from the beginning were there would be no matrix and nothing that's equivalent to a central processing engine. Completely gone. We want it to be familiar to operators. Ultimately, people want a gooseneck microphone. They want to be able to plug a headset in. They want to be able to push some buttons. They need to be able to hear who's communicating with them, of course. I think that's a given. But so some bits don't change. Some bits look familiar, whether it's in a intercom hardware at any rate. We needed to meet people's expectations, of course. So we need to design a product that does what people need it to do and not skimp on functionality. As a result, we don't have decades of intercom experience, so we're not going to be able to do everything in one go, but ultimately come up with a subset of functionality and at least start in a good place when we launched. Make it entirely standards-based. Blanket rule, nothing in there isn't standard. It's all standards-based. It's not proprietary in any way whatsoever. So whether it's RTP or AES67, whether it's the use of SIP or VoIP standards, they're all standards-based. And it can become a native part of a SMPTE 2110-30 system or a 2110 ecosystem as a whole. Because we didn't know about SMPTE 2110 when we started the project, we know about AES67, and as luck would have it, SMPTE 2110 adopted AES67, so it becomes a native piece of that picture. Scalability and resilience is a massively important part of the overall message. We need it to be resilient, and we can be resilient by not having single points of failure, and we can be scalable by the fact that we're not bound by a frame, and that if you want to add devices and you've got room on your network, you can add devices and your intercom system scales up accordingly. We also recognize that at broadcasters around the world, there tends to be the guy who does the comms. You know, there is often, he's the comms guy, so he's off on vacation, we can't change anything on the comms system. Well, there might be one or two, but there's very often people who have a level of expertise that's built up on intercom, because intercom's kind of a black art, a bit like doing control systems, but it's still a black art that few people truly understand the minutiae of a comms system. So we wanted to try and get over that and make it simpler for people to program, to use, to understand. Because after all, we all communicate all the time. We use our cell phones with impunity. We expect to be able to press a few digits and speak to somebody on the other side of the world. So why shouldn't intercom be the same? Why shouldn't we be able to just pick up an intercom system and use it without having to, you know, get in there and have to change the oil every time we need to do something different. And there's a natural complexity to what we've done, but we want that hidden under the hood. You don't need to know about it. If you're an inquisitive engineer, you'll want to know about it, but most of the people who are using Infinity now really just want it to work like an intercom system. And also then, by utilizing IP technology and by being able to take a stand back and not being encumbered by what's gone before, we can also do things differently. We can, it's a cliche, but we can look outside the box, look outside the blue sky box thing. You know what I'm saying. We can do things differently. So Telos Infinity is what we came up with, which was shown here at IBC in 2017 for the first time. It started shipping in 2018. And the overview is it's all new. We hit the mark with a fully standards-based system. There is no matrix. We haven't skimped on functionality. It's scalable, meaning it can, if you're a very, very, very competent network designer, you could probably have tens of thousands of panels. You'd have to be very good, but you could. Especially Eurosport. Eurosport could have anything they want, obviously. Seamless integration with VoIP products, with SIP codecs. We also use an Opus server as part of the system to allow us to communicate with extendable systems beyond the boundaries of LAN. And because it's based on AES-67, SMPTE 211030, it blurs the line between communication and contribution, meaning that audio over IP that's on the same network as the comm system natively becomes part of what you can communicate with. So that means that a presenter's microphone that's feeding the console can also be the same multicast stream that feeds the IFB reverse on the IFB key or a pre-hear key. And we created a UI that we believe is modern and intuitive. So I'm very conscious of the time, and I want to leave some time for questions. And I do have a few slides to go, so I'll whiz through. In very basic terms, that's what a small Infinity system looks like. The thing that looks like a bit of candy over here is the network backbone. So let's call it a switch. So that's what it is, and everything just plugs into it. So the panels just plug into it. The baseband conversion, X nodes in our case, or they could be from any other company, plug straight into the network, and they appear as though they are a part of an intercom system. So when you run up the UI, you get a picture of some panels and a whole load of I/O ports, and they're IP, but they look like they're part of an intercom system. So even the small one we have on the booth here is around about a 300 port system, but it's all just been discovered and become part of the intercom system, whether it's something coming off a mixing console or off a telco product or whatever else. So when you start to scale up, it's your network that scales up, and you still have that ability to extend the system, to add panels, add devices, et cetera, et cetera. And then ultimately, once you get beyond the boundaries of your own site, and you start to get into a place where your bandwidth might be pinched, and you have to connect over WAN, again, the Infinity system can do that. So we can join multiple sites together, like Eurosport, of course. So how do we do it? Well, this is looking inside the devices and looking inside the network a little bit. On the top there, the top sort of sausage-shaped thing, could be an Infinity panel or it could be a belt pack. But basically, they have the same fundamental component parts. So you've got your baseband interfaces. You've got a mic, headset, connector, auxiliary inputs if you buy that panel with the auxiliaries. And then on the other side, on the right-hand side, speaker, headset output to your earpiece, and also auxiliary output. So that interface into the D2As and A to Ds obviously exists in the panel. The core of what makes this work with the distributed system, the way that we can do a matrix-free system is by putting DSP in every device, so that when you create a party line, everybody that's conferencing can be heard at every location that's subscribed to it by having a whole load of mix engines and also a whole load of AES-67 receivers and transmitters. So that's the secret sauce inside there, is this combination of mix engines and AES-67 send and receive devices. So if a panel subscribes to another panel via a key, and one talks to the other, subscribes to the multicast stream, here's the audio. If it's subscribing to a conference, 3 people talk at the same time, the panels mix together the streams, and they listen to what's going on. If a device is on the network which converts AES-67 to analog to feed an IFB transmitter, for example, then when you create that IFB, mix resources are allocated to various mix engines around the network, and that IFB is fed from distributed resources, so everything distributes like that. Embedded UI and a web server inside every panel, so you can configure them locally, and it also means that the server that manages the system during the configuration phase can also lock on and configure. Physical UI, buttons, and knobs. And then we have a product called Dashboard. And Dashboard is the device discovery and system management portion of the product that looks inside the network and says, there's a panel there, panel there, panel there. Here's a whole load of streams coming in. Here's a load of streams going out. Here's some telephony. Here's some AES-67 from another manufacturer coming in. Here's some AES-67 going out to another device from a third party. This is what I use to create my overview of what an intercom system now looks like in my IP world, with no real ports apart from Ethernet ports to worry about. And that database has a web server connection that allows you to view it as an intercom system. And then running through rather quickly, third-party devices that can be discovered using different protocols. We're not quite there with Infinity on NMOS. That's been done on a lot of our other products, but NMOS is not far down the line in the future. And then ultimately other devices from our own stable that appear on the network. So my last slide, before we get to questions, just unlock a little bit of the detail behind what's going on. How do I create an IFB? So here's a very simple system. I've got a couple of panels. I've got my dashboard software. I've got a mixing console providing me with mix minuses, and I've got an analog X node, which is a AES-67 to baseband converter that's feeding the presenter down there in the bottom right corner. So using dashboard, I create the notion of an IFB. The intercom system says, great, I've got to create an IFB, and it will allocate mixed resources in 2 locations, a primary and a secondary, So I have a backup in case somebody unplugs one to charge their cell phone. I add a source from the console. This is my mix minus. It will be routed to the primary and secondary mixers simultaneously, although I've only shown it going to the primary. Bad drawing. And as you add the destination being the X node that is feeding the earpiece, that subscribes to the transmitter inside the IFB mixer. Destination subscribes to the multicast address, as I just said. That mix minus then becomes routed to the primary IFB mixer, and the destination will then hear the mix minus. So that happens automatically. As soon as you make that route, IFB hears the mix minus. I add a key to my panel that's associated with that IFB, and if I press the button, that route to the presenter is made through the IFB that I've created in the distributed environment, and it's ducked inside the mixer, inside the distributed mix environment. So that's actually it. That's an insight into the Infinity system and how 2110 influenced what we did.
Okay, Martin, thank you very much. We've got time for a couple questions. One question I had, your database down in the corner, what do you call it, Discover?
Dashboard, because we thought long and hard about names.
Okay, so dashboard, okay.
We had a competition, 10 people entered the word dashboard, so we chose it.
There you go. That's good. So is that based on open standards, or is that something that's, or is it open source, or is it something that's...
It actually uses an SQL database, but it uses the Livewire protocol, which is part of our the Livewire standard.
Right.
And unless you and we currently if you add non-Telos devices, so if you add something from an Ordinate partner or from a Ravenna partner, then rather than discover absolutely everything on the network automatically, it allows you to do a manual selection. So you add external devices. Otherwise, you could end up with 10,000 sources and destinations when really all you wanted was eight mix minuses.
Right.
So it allows you to pick and choose.
Okay, very good. Anybody else? Yep, hold on.
Yeah, quick question. You mentioned early stages of NMOS implementation. So third-party discovery of endpoints is ISO 4. If you are requiring them to subscribe to something you're sending, you use ISO 5.
Yeah.
Are you also looking at ISO 7 for event and tally and ISO 8 for channel manipulation?
Yeah, potentially.
Yeah.
I mean, at the moment, we're looking at 4 and 5. I do sort of look across the CTO here because ultimately he's in charge of direction. But yes, we're like many people watching the industry and also listening to our customers to figure out what we need to do beyond 4 and 5. And with an intercom system, it's a little bit different, I guess, because much of the external connectivity will be fixed once it's made. I mean, not always, of course, but and also potentially under control from third-party devices as well. So I think everything's going to be on a case-by-case basis, and we'll look to technology to figure that out.
Because I think one of the key differentiators between the way Dante works, it's a channel first, streams follow. AS67 is you connect streams and it contains channels.
Yeah.
A definable number of channels.
Yeah.
And you're not going to have a level playing field between all of the different participants.
No.
So intercom is traditionally a mono game. To get the right channel to reach the right endpoint, an element of ISO 8 is really going to be fairly fundamental.
Yeah, no, I totally get that. And we've already had a number of customers who've asked how we're going to deal with a 64-channel stream, how we're going to deal with a 16-channel stream. And it's something that across the company's entire range of products, especially those ones in the TV space, not so much radio, but in the TV space, we recognize we have to do that. So any technology that we develop in one platform can be extended across other platforms. And at the moment, you know, if we analyze the SDP information from an incoming stream, and we recognize that we can't handle it because it's 64 wide, then we have to go back to the source and adapt it. But in the future, that's something that we won't have to do. And it'll be project driven.
Okay, Martin, thank you very much. And
Thank you.
we'll getting our next speaker prepared. We'll be back on stage in a minute or two.